everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, the topic we are going to discuss about finite Fourier transforms. Definition of finite Fourier transforms, problems on finite Fourier transforms. These are the two topics in detail we will discuss in this video lecture. The definition of finite Fourier transforms. That is, the first formula is the symbol, what I circled here. Capital F represents Fourier transform. The small s represents Fourier sine transform of the function f of x, which is equal to capital F s of n, equal to the given function f of x, which is multiplied by sine of n pi x by L, and we have to do the integration with respect to x, 0 to L. Next, inverse finite Fourier sine transform. In this particular formula, the function f of x will be written out. The Fourier sine transform will go inside this summation. So capital F s of n, the summation, this n is taking the value from 1 to infinity into sine of n pi x by L. Everything is multiplied by 2 by L. Here this L is finite. The next formula is finite Fourier cosine transform formula. That is, if we do this comparison study between finite Fourier sine transform and finite Fourier cosine transform, just the s is replaced by c. So here also integral 0 to L f of x, which is multiplied by sine of n pi x by L. Here f of x is multiplied by cos of n pi x by L dx. Now, inverse finite Fourier cosine transform formula is, that is, here the function is coming out, f of x equal to 1 by L, capital FC, capital FC, how to be read, that is Fourier cosine of, at the point 0 plus 2 by L, summation n equal to 1 to infinity, Fourier cosine transform into cos of n pi x by L. So, the finite, the transforms, summation is playing the role. So, we have to do the comparison study, which is very useful to remember, for which we won't get any careless mistakes. The first problem, find the finite Fourier sine and cosine transforms of f of x equal to 1. So clearly it is given, use finite Fourier sine transform and finite cosine transform of f of x equal to 1. The solution, the finite Fourier, the sine transform formula is capital F s of f of x equal to capital F s of n equal to integral 0 to L, this f of x is multiplied by sine of n pi x by L dx to be written here. Now, so we are taking help from this Fourier, finite Fourier sine transform. The formula is written. In the formula, it is 0 to L is there. Here also it should be given the interval, that is 0 to pi in the question, it should be, it is not written. 0 to pi it is there. So 0 to pi, and f of x is replaced by, the question it is given, 1. It is written sine of n pi x by L. Our L is, that is 0 to L is pi. So it is written, the pi getting cancelled. So the remaining is 0 to pi sine nx dx. So the complete our question is find finite Fourier sine transform for the function f of x equal to 1 in the interval 0, pi. Now, so 0 to pi sine nx dx, we have to do the integration. Sin x integration is minus cos nx, that is sin x integral is minus cos x. X coefficient is 1. Now ours is sin nx, so minus cos nx, x coefficient is n. So divided by n, 0 to pi. We did the integration with respect to x. So in the place of x, we will substitute pi. So this minus 1 by n, which is written outside, the remaining cos nx 0 to pi. So we substituted here, this minus 1 by n is written as it is. Cos, the upper limit is pi. So cos n pi, this is the upper limit purpose, we substituted. This is limit formula, that is between upper limit minus lower limit. Our lower limit is 0. We substituted in the x place, cos 0 value is 1. Now, so minus 1 by n. So cos n pi, it's nothing but minus 1 power n minus 1. So now 1 by n it is written here. We have taken this minus sign inside. So it has become now minus here. That's what this term. And minus into minus, it has become plus 1. We completed finite Fourier sine transform. The question is asked one more, finite Fourier cosine transform formula. So the formula is fc of f of x equal to fc of n equal to, that is f of x, which is multiplied by cos of n pi x by L dx. 0 to L. Our f of x is 1 into cos of n pi x by L is replaced by pi because our interval is 0, pi. So L is playing the role. The length of the interval is pi. This pi cancelled. So the remaining is integral 0 to pi cos nx dx. Now cos nx is, we will do the integration for cos integral is sin nx divided by x coefficient is n. So 0 to pi. This 1 by pi it has taken out. Sin nx 0 to pi. Now 1 by pi, sin n pi, the value is 0. Upper limit we substituted. That is our upper limit is pi. In the place of x we substituted. We got sin n pi equal to 0. Now here x place we will substitute 0. Sin 0 is 0. This is formula minus. That is upper limit minus lower limit. So everything it is becoming, the solution is 0. But strictly here we wrote it, n should not be also not equal to 0. The reason is, if n is taking the value 0, 1 by 0 here, 1 by 0 is infinity. It should not be there. That is the reason here it is written. So the complete one problem, that is f of x equal to 1 in the interval 0, pi, we completed it. The second problem is find the finite sine and cosine transforms of f of x. Here the f of x equal to, the f of x is defined by x, where x lies between 0 and 4. The solution is finite Fourier. The sine transform formula is capital Fs of f of x equal to capital Fs of n, which is equal to the given function, whatever the equation which is given, that is ours is x, which should be multiplied by sine of n pi x by L. L is nothing but our length of the interval. Our length of the interval is 0 to 4. That means L is going to take the value 4. Where is L? Here and here. Both the places, the L to be replaced by, according to our problem, 4. So 0 to 4, x sine of n pi x by 4 dx to be written here. So we did the integration, that is, here algebraic this part is trigonometric oriented. What I am going to do, the algebraic part first I am writing here, that is algebraic part, the differentiation is 1. The trigonometric part, I will do the integration cos of n pi x by 4 divided by x coefficient is n pi by 4. Now again this I will do the integration minus sine of n pi x by 4 divided by n pi by 4 the whole square. This is a very simple technique of integration, that is, if algebraic part comes, we will do complete differentiation, we will concentrate. The trigonometric oriented, we will integrate and first we will write and keep on, we will do the integration. Then this and this should be multiplied. So we can see it here. So x is written. This particular part, it is written here. The 1 is written here. And this part, it is written here. I stopped this procedure. The reason is 1 differentiation is 0. After integrating, once we can recheck it, whether we did correct or not. Algebra, going on, differentiation, correct. Trigonometry, integrated, and we wrote, going on, continuing the procedure with integration. The middle, this sign is nothing but alternative sign to be followed in this type of integration. The procedure is stopped because 1 again the differentiation is 0. That is the reason the integration is stopped up to here, 0 to 4. Now, we didn't actually immediately applying 0 to 4. Is there any simplifications? Here, n pi by 4 is there. We are bringing up. It is becoming 4 by n pi. This minus sign, here it is there. The remaining we didn't touch, it is written as it is. This minus, it has become plus. Now n pi by 4 the whole square. So the up has become up. 16 by n square pi square, sine of n pi x by 4, 0 to 4. Now we are applying the limit. That is, upper limit is 4. The lower limit is 0. The upper limit, in the place of x, first we will substitute. That is minus 4 into, here x is taking the value 4. It has become minus 16. This n pi, it is written as it is. Here x place we are putting 4. This 4 cancelled. Cos n pi, the value is minus 1 power n. That we substituted. Here we are writing 4. Cancel. Sine n pi equal to 0. We completed the upper limit, that is x place taking the value as 4. Formula minus, and the lower one is 0. That is x place we have to put it 0. So 0, here x is taking the lower limit. 0 into anything 0, plus here also sine 0, x plus 0 we are putting, sine 0 is 0. We completed the limit, upper limit to minus lower limit. So this is the final answer. We got it. Minus 16 of minus 1 power n by n pi. If more one simplification required also, we can write 16 into minus 1 into minus 1 power n by n pi. 16 minus 1 power n plus 1 by n pi. We can more, if it is possible also, we can write. Otherwise, we can stop up to here also. It is correct. That is minus 1. The minus is written as minus 1. We applied the exponential law. That is minus 1 power 1. Minus 1 power n. So 1 and n we added. So it has become n plus 1. The denominator is n pi is written as it is. Next, finite Fourier cosine transform formula. So this is the formula for finite Fourier cosine transform. That is capital FC of f of x. It's nothing but capital FC of n. Integral 0 to L, that f of x is multiplied by cos of n pi x by L dx. 0 to 4 x cos of n pi x by 4. That is our given function is f of x. Interval is 0, 4. So L is playing the role 4. So the two places the L is there in the formula, they are replaced by 4 dx to be written here. So we are doing the integration with respect to x. So now in this, the algebraic part is this one. The trigonometric part is this one. So we know it, the algebraic part we will do going on differentiation. We can check it. X is written. X differentiation is 1. This is trigonometric term. First we will do the integration. Here it is there. That is cos integral is sine n pi x by 4. So sine of n pi x by 4 divided by the coefficient of x is n pi by 4. Again, this integration, trigonometric term, we will use the integration. The sine integral is minus cos. cos of n pi x by 4 divided by n pi by 4, but already here n pi by 4 it is there. That is the reason n pi by 4 the whole square. Everything we touched in this except this one. This is formula minus of this particular type of integration doing. 0 to 4 is our limits. Now we will do the simplifications first. This n pi by 4 which is written up. So 4 by n pi, you can see it here. X sine of n pi x by 4. This minus put together, it is plus n pi by 4, that is n square pi square by 16. Upcoming 16 by n square pi square. Cos of n pi x by 4, 0 to 4. Now we will substitute the upper limit, that is 4, in the place of x, because we did the integration with respect to x. So we can substitute in the place of x. Here x is taking 4, 4 cancelled. Sine of n pi, the value is 0. So we got it 0, plus this is written as it is. Here it is written as it is. X is taking the value 4. Now we are concentrating this upper limit. 4 cancelled. The remaining is cos of n pi. Cos of n pi, it's nothing but minus 1 power n. Completely, the upper limit is completed. The term is not there. Completed. This is formula minus for the limit. Now we will focus on the lower limit. The lower limit is 0. In the place of x we are substituting 0 into anything 0. This term it is written as it is. Here x place we are putting 0. So cos of 0, it's nothing but cos 0 value is 1. This particular 16 by n square pi square into 1 is 16 by n square pi square. In this here, both the terms 16 by n square pi square is common. Here the leftover is minus 1 power n. This minus is here. Here everything it has come out. So the remaining is 1. So the next problem we will concentrate. Find the finite Fourier sine and cosine transforms of f of x equal to 2x. X lies between 0 to 2 pi. The solution is the finite Fourier sine transform formula is capital Fs of f of x is nothing but capital Fs of n equal to integral 0 to L, the given function f of x, which is multiplied by sine of n pi x by L dx. Now, our given problem, x lies between 0 to 2 pi it is there. That is, the L is replaced by 2 pi. So the 2 places, the 2 pi it is written. F of x is replaced by our function 2x. Sine of n pi x by 2 pi. Pi getting cancelled. So integral 0 to 2 pi. This 2x is written as it is. Sine of, after getting cancelled pi, the remaining is sine of nx by 2. Now the integration is, this is the algebraic oriented. So the algebraic oriented, we know it. Going on, we will do the differentiation. Yes, it is correct. 2x, the differentiation is 2. The middle, we will keep the alternative signs. Minus is there. The trigonometric oriented, we will do going on integration. The first, the sine integration is minus cos. Our is sine of nx by 2. So, sine integral is minus cos of nx by 2. The x coefficient is divided by n by 2. So, this trigonometric oriented, we have to do, keep on integrating. So, this minus is written as it is. Cos integration is sine. So, sine of nx by 2 by n by 2 the whole square. So, we have to do 0 to 2 pi. So, the last step, it is written again once again. Here we are doing the simplifications. That is n by 2, it is there here. That we brought it up. It has become 2 by n. So, multiplying 4x by n. This minus sign is as it is. Cos of nx by 2. This minus put together, it has become plus. This is n square by 4. We are bringing up, it has become 4 by n square. So, it is 8 by n square. Sine of nx by 2. Now, we will apply at most what are the simplifications are there regarding signs. Completion of that, if we apply the limits, there is no room for careless mistakes. Now, x is going to take the value, the upper limit 2 pi. That is, this minus is here, 4. X is taking the value 2 pi. So, 4 into 2 pi is nothing but 8 pi. 8 pi by n. Now, cos of nx by 2. So, x place we will put it 2 pi. 2 getting cancelled. Cos of n pi, it's nothing but the formula minus 1 power n. Now, plus 8 by n square. Here x is taking 2 pi. 2 cancelled. But sine of n pi, the value is 0. So, we completed the upper limit. This is formula minus. Now, we will touch the lower limit. In the place of x, we will substitute 0. That is our lower limit. 0 into anything 0 plus 8 by n square. X place we will put it 0. Sine of 0 is nothing but 0. So now the simplifications, finally we got the result minus 8 pi into minus 1 power n by n. This minus sign, it is written as minus 1 power 1. This is minus 1 power n. Put together, bases are same. We can add the powers. So, it has become minus 1 power n plus 1. So, the next one is finite Fourier cosine transform formula. Now, capital F, C of f of x equal to capital F, C of n equal to integral 0 to L f of x is multiplied by cos of n pi x by L dx should be there. That is, we are doing the integration with respect to x. Now, integral 0 to 2 pi, that is, our L is 2 pi, our function is f of x, cos of n pi x by L, L is 2 pi, the pi getting cancelled. So we got it, integral 0 to 2 pi, the 2x is written as it is. After getting pi cancelled, it is cos of nx by 2 dx. Now, we will do the integration. This is algebraic oriented. This is trigonometric oriented. So, the algebraic part is written here first. That we will write going on differentiation. 2x differentiation is 2. This middle one is formula sign minus. This is the trigonometric term that we will integrate and we will write it. Cos integral is sine of nx by 2 divided by x coefficient is n by 2, that is written here. This trigonometric term keep on integrating. That is the reason the sine integral is minus cos of nx by 2 divided by x coefficient is n by 2. Actually here n by 2 should be, but already the before one n by 2 put together it is becoming n by 2 the whole square. Now we will do the simplification. Before applying this upper limit 2 pi, the lower limit 0. Here n by 2 is there. That we will bring up. That is, it is multiplied by 2 by n. So it is 4x by n of, this is written as it is, sine of nx by 2. This minus it has become plus. Here it is n square by 4. We are bringing up, then it is becoming 4 by n square. So 8 by n square cos of nx by 2. Now we will substitute in the place of x 2 pi. Here also we will apply 2 pi. 2 getting cancelled, sine of n pi, the value is 0, plus 8 by n square, it is written as it is. X is replaced by 2 pi, 2 getting cancelled. Cos of n pi, it's nothing but minus 1 power n. Completely the upper limit we completed. The middle one is formula minus. The lower limit is 0. So 0 into anything, that is x is replaced by 0. 0 into anything, 0. This plus is written as it is. 8 by n square, it is written as it is. Cos of x is replaced by 0. So n into 0, 0. Cos 0 is 1. So 8 by n square is multiplied by 1. It's nothing but 8 by n square. So both the terms 8 by n square is common. The first term, the remaining is minus 1 power n. The second one is minus 1. We will concentrate the next problem. Find the finite Fourier Sine transform of f of x equal to x by pi, where x lies between 0 to pi. Solution: finite Fourier sine transform formula is capital F of S f of x, capital F S of n, integral 0 to L f of x, sine of n pi x by L dx. Now 0 to pi, that is 0 to L, ours is 0 to pi, L is taking. The two places are replaced by our given problem, the limit pi. F of x is replaced by our given function x by pi into sine of n pi x by L, our L is pi. This pi getting cancelled, so we are getting integral 0 to pi, our function x by pi, and this we cancelled it. So we got sine nx dx. We will do the integration, that is a simple integration if it is the combination of algebraic and trigonometric terms. So now x by n, algebraic oriented, this differentiation is x by pi, 1 by pi, the differentiation, sine nx, we will integrate it, cos nx by n, again we will do the integration, sine nx by n, already n is there, that is the reason here n square. This into this, that's what here it is written. This is formula sine. This into this, here it is written. This way, if it is possible, we can do it. Otherwise, algebraic, keep on differentiation. Trigonometry, keep on integrating. The middle one is alternative signs. Alternative signs in the sense, suppose the integration we are extending, next plus will come, next minus, it goes on. The limit is 0 to pi. Now, x place upper limit we will substitute, that is pi. So first we will do the simplification before applying the limit. This minus sign, it is kept here. X is as it is. This both put together, n pi, minus into minus, it has become plus, sine nx, pi into n square, pi n square, 0 to pi. X place we are putting pi, that is x is replaced by pi, pi cancelled. This minus sign as it is, this n is as it is, x is replaced by pi, that is cos n pi. Cos n pi, the value is minus 1 power n. This plus is as it is. Sin n pi is nothing but 0. So we completed the upper limit. It is not written the lower limit, that is minus. It is 0, that's what it is neglected. That is formula minus. The lower limit is 0. 0 into x is replaced by 0. 0 into anything 0. Sin 0, 0. So we got it. The simplification is that minus is written minus 1 power 1 minus 1 power n. This put together, the bases minus 1 minus 1. So we added the powers according to exponential law. A power m into a power n, which is nothing but a power m plus n. Using that, it is written minus 1 power n plus 1 divided by this n. Yeah, we will come to a conclusion. It is a finite Fourier transform. The definition of finite Fourier transforms. First, in detail, we concentrated what is finite Fourier transform, in that the two formulas, finite Fourier sine, finite Fourier cosine transform, we discussed. The problems we selected: find the finite Fourier sine and cosine transforms for the function f of x equal to 1. The next problem, f of x equal to x for the interval x lies between 0 to 4. So here the L is playing the role 4. The first problem 0, pi. Here L is played the role pi. And the third problem we discussed, f of x equal to 2x. X lies between 2 to pi. Here L is played a role 2 pi. The last problem, f of x, we have taken x by pi. Here x lies between 0 to pi. L is playing the role pi. So the finite transform, the limits are finite. In detail, we discussed taking these 4 problems. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.